Hello everyone. Today we're going to be talking about another type of transformation you can do on trigonometric graphs, which is affecting the frequency or the period. It's also called horizontal dilation. I'm going to show you on Desmos and we can get started. Alright, so you see here that what I have once again is the sine of x function and this other sine of x function which has all of these coefficients and constants and other stuff that I can use to modify. And we've already spoken about what A and B do, and now you can see we have this new constant, not a variable, C, which is going to control something called the period or the frequency, and it's going to do that by using a transformation called horizontal dilation. So essentially what's happening is I want you to imagine that you are proceeding through all of the values of x that you would normally proceed through in sine. So let's say you're normally going to go 0, pi over 6, pi over 4, pi over 3, pi. You're going to hit those values. Now, if I put in a number in here, what that's going to do is it's going to adjust the speed at which I will reach those values. So for example, if I put in a 2, that means where usually I would have to wait until x got to pi over 6 in order to reach 0.5. If this is a 2 in here, that means I can reach 0.5 at pi over 12. I can reach it sooner. So by inputting a 2, I'm actually increasing the speed through which the x values are producing the y values. So that is going to increase the speed, also known as the frequency of the graph, and it's going to increase the period. The period will it will decrease the period. Because it's faster, the period will shrink. It'll become shorter. So I have here this slider. You can see what happens is if I double this, right? So normally the graph will right here at 2 pi comma 0 in the red, you see it has completed one cycle. It has gone up, it's come down, right? So it's gone up here, it's come down here, and then it's completed one cycle. But if we look at the blue graph, we can see it's gone up, come down, completed its cycle. Let's get rid of these. And then it's gone up, come down, and then completed another cycle. So the graph is going twice as fast. I can fit twice as many cycles into the same period. So we say that the period of the cycle has decreased, it's gotten shorter. You can say the frequency has increased, and that's caused by horizontal dilation. So the variable, or I keep saying variable, I mean constant, the constant that's here has an inverse relationship with the period. So the higher this number goes, the smaller the period will get, and vice versa. If this gets really small, closer and closer to 0, the period will get larger and larger. However, it has a direct relation to the frequency, which is the amount of times that you'll go through a complete cycle in that span from 0 to 2 pi. So right now, C is 2. It's going to complete 2 cycles from 0 to 2 pi. If I put in a 3, it'll complete 3 cycles in the same time. If I put in a half, it completes exactly half a cycle in that time. So there's two things at play here. There's the frequency, which is directly affected. It's a direct relationship with this constant C. And then there's the period, which is an inverse relationship. So the smaller that C is, closer to 0, the larger that the period will be. the larger that C is, the smaller the period will be. And again, the name of this transformation is called the horizontal dilation. So I hope that gives you some good information about horizontal dilation, period, frequency, and how those are all interconnected. If you have any questions, please post them in the video, and also please like and subscribe because that does help out the channel.